So the key is like how to solve this kind of question where there's a few modulus. So one way is to split it into parts, right? So first thing, because I noticed there are three numbers, x plus 1, x minus 2, and x minus 3. So the corresponding numbers are 3, 2, and minus 1. So let's say when x, so I mark out the boundary, so when x is greater than 3, when x is greater than 3, this is a positive number. So the modulus does not matter. So when x is greater than 3, for example, 4 minus 3 is equals to 1. Whether I put the modulus or not does not matter. So I remove the modulus, right? So, and the same thing happens for this and this as well, because 3 plus 1 is anything greater than 3 when add to 1 will be a positive number. When it's a positive number, the modulus doesn't matter. 3 minus 2 is a positive number, and any number greater than 3 minus 2 positive number. So I remove the modulus and it doesn't matter. So when x is greater than 3, I can just change the equation to x plus 1 plus x minus 2 plus 2 times x minus 3. It won't make a difference whether I put the modulus or not. So I solve for this part. So x plus x, 2x, 2x plus 2x is 4x, correct? So 1 minus 2 is minus 1. Minus 1 minus 6 is minus 7. So minus 7 smaller than 10. And I can proceed to say 4x is smaller than 17, correct? And then my x is smaller than 17 over 4. So 17 over 4 must fit with this. So let's say if I say 3 greater, this part is greater than 3, right? And 17 over 4 is just equals to 4, 3, 12. Oh no, 4, 4, 16. 16 and 4, 4, 16, 4 and 1 quarter. So 4 and 1 quarter is somewhere here, right? 4 and 1 quarter somewhere here. So I want this part to this part. So that means, yep. That means my answer for this part when x greater than 3, right, is x is smaller than 4 and 1 quarter, 4 and 1 quarter, and greater than 3, x greater than 3. See, so 4 and 1 quarter, if I substitute inside, do I get 10? I believe so. So I take 4 and 1 quarter, I substitute. So I take 17 over 4. So 1 plus 17 over 4 plus 17 over 4 minus 2, right, plus 2 times 17 over 4, right, 17 over 4 minus 3. 17 over 4 is just 4 and 1 quarter lah. So from this one would get 21 over 4 plus this one is 4 and 1 quarter minus 2 is 2 and 1 quarter plus 2 times 4 and 1 quarter minus 3 is 1 and 1 quarter, correct? 1 and 1 quarter. So 1 and 1 quarter. Doesn't matter the modulus because these are all positive numbers. So this one will give me 21 over 4 plus what? 9 over 4 plus 5 over 4. So 10 over 4. Right. 2 times 5, 10 over 4. So all 10, 19 plus 21 is what? 19 plus 21 is equals to 40 over 4. So this one will give me exactly 10. So if my x is 4 and 1 quarter, I get 10. But we don't want to be at 10. We want it smaller than 10. Yeah. So that's why here we have a 4 and 1 quarter. So this part is only I'm doing this to check only. This is not necessary. And check why this 4 and 1 quarter is so special value. I can derive straight away from here. It's not necessary to do the checking. To solve this question, I just want to be sure. So now from here, this is not all, of course, because we have checked we need to check for all values of x. This one cover for all values that are greater than 3. Now we need to move to a value like 3. What happens at 3? When x equals to 3, this value is 4. X plus 1 modulus becomes 4. Then this part becomes 3 minus 2 is 1. 1 modulus is 1. And this one, 3 minus 3 is 0. 0 times 2 is 0. So 4 plus 1 is definitely smaller than 10. So that means 3 is an accepted value. 3, when I plug in, I get 5, which is smaller than 10. So 3 is one of the value that I want. So far I have gotten this these two value. How about when x is between 2 and 3? We want to check the values between these two. Just now we checked here already, this covered, now 3 covered. So we want to check what if our x values is between 2 and 3. If it is between 2 and 3, then my this value would be a positive number, because any number between 2 and 3 add to 1 is so it's positive number. It doesn't matter whether the modulus sign is there or not. But let's say if between 2 and 3, it means greater than 2. Greater than 2, when I sub minus 2, I'll get a positive number. So it doesn't matter whether the modular sign is there or not. Then when it is smaller than 3, now when this is smaller than 3, for example 2.5, something like in this range. So 2.5 minus 3, I will get a negative number. When I get a negative number, the modulus make it into a positive number. Therefore, actually between here and here, my x minus 3 is equals to minus x minus 3. Don't believe? Substitute any number, 2.5, substitute inside. 2.5 minus 3 modulus equals to minus 2.5 minus 3. So I get 2.5 minus 3 is minus 0.5 modulus. I get 0.5 modulus minus 0.5 is 0.5. So this part, what do I get? This part I get minus 2.5 minus 3 is minus 0.5. Minus 0.5 times minus, I get positive 0.5 as well. Therefore, my equation between this range, my x minus 3 is equals to minus x minus 3. So I'll have it like this one, minus x minus 3. Like this kind of logic in the beginning, when you do, you may feel that, wow, I need to go through so much thinking, then you will waste so much time in an exam. But actually, it's not necessary. Once you are very familiar with it, right, actually you can straight away know that when any number is less than this 3, right, it will be negative. To become positive number is just add a minus sign in front. You will become very of a second nature to you, and you will be able to solve this type of question very fast. So x plus x is 2x, 2x minus, so now there's a 2 in front that I have left out, so this should be a 2. Okay, so the negative sign, I just, instead of adding to this, I add to in front of, change this plus to minus, so I change it to, because now my x is smaller than 3. So when it passes to less than 2, my x minus 2 also need to change to minus 2. Later we'll see that. So now I'll just add this first. So x plus x is 2x, 2x minus x is 2x minus 2 times x is 0. So I no longer have a x, correct? So 1 minus 2 is minus 1, minus 1 plus 6, 2 minus 2 times minus 1 plus 6 is 5. So double check, 1 minus 1 plus 6 is 5. 5 is smaller than 10. That means all these values are accepted. So that means 2x smaller than 3 satisfy this equation. If you choose any number between 2 and 3, you plug inside, you will satisfy this equation. Okay? And hence we put a tick here. Alright, and the next thing is that means actually if we substitute any value between 2 and 3, right, we will actually get to a 5. You want to test that? Okay, so because just now we have proved that, so because the 2x will disappear, so actually let's say if I put a 2.5, I get a 3.5 plus 2.5, I get a minus 0.5, which become a positive 0.5, then plus 2.5, this one will get 0.5 plus 2 times 0.5. Okay, it's 2.5. I'm substituting 2.5 into all the x values. So 2.5 minus 3, you get minus 0.5, minus 0.5 modulus becomes positive 0.5. So 0.5 plus 3.5 is 4. 4 plus 2 times 0.5 is 1. Indeed, we get the 5. No matter what is the value they substitute. It's strange, but it happens. Because just now, you see that, yep, when you substitute this, the 2x disappear. So you always get a constant 5 value. So 5 is always smaller than 10, so this part of this range of values is accepted by me. So now we need to check. Now we have fallen into this range. Now we want to check x equals to 2. What happens when x equals to 2? Let's say x equals to 2, then this one, 2 plus 1 is 3. 3 modulus is just 3. I can ignore the modulus actually. So 2 2 minus 2 I get 0, and 2 minus 3 is minus 1. Minus 1 modulus become positive 1, so 2 plus positive 1, so actually minus 1. So then but it's the same as, okay, so then this one I will give, you will give me 3 minus 2, no, 3 plus 2. 3 plus 2, 3 plus 2 will give me 5 also. 5 also is smaller than the 10, so it's satisfied. So that means I will accept my value 2. I've checked that, this one. So later we add all these numbers, all this let up. Also, you see on the number line just now was here to here, right? Now because I accepted 3, so this become a black dot. Then 2 to 3 I accepted, and I accepted 2. So that means I also accepted this range, right? Okay, I accepted all this range of values. Now we are considering this part by part, so the range are the fields are adding up. It's a bit different from the usual way that we do inequality, where when we do n, when it's n, right, we only highlight the, just now like in the first part, these two has to be concurrently accepted. So this and this must be concurrent. That's why we only take the overlapping part. But across these are separate cases. We call them all. They are all cases. So it's a union. This is the intercept. N for n is intercept. All is union. So, but maybe now you are not familiar with this concept yet. But as you learn set theory and other, like when you learn probability things like that, then you understand this concept better. But for now, you just could accept that. This. So now let's say if we go to x between, now we are going to check for this region, which is minus 1 to 2. So let's say from minus 1 to 2, now my number has become smaller than 2. When it's smaller than 2, then this part, this x plus 1, I can still be positive because the number is still greater than minus 1. So this is still a positive number. So if it's a positive number, the modulus doesn't matter. Now if smaller than 2, then when smaller than 2 minus 2, I'll get a negative number inside. Negative number inside, when the modulus actually become a positive number, and it happens if I add the minus sign in front of this. We already explained earlier. If you want, you can scroll back to when I explained for why I put a minus sign in front of the 2 when I do this region, and you will get the same logic here, right? Why I add a negative now is because, okay, let's say maybe I do it again. So let's say I choose a number between here and here, could be 1.7. So 1.7 minus 2 could be any number. So this one would be minus 1, this one would be minus 0.3 modulus, right? Minus 0.3 modulus is just 0.3. It is equal to, writing this, equals to minus times 1.7 minus 2, correct? This is minus 0.3 times minus, you get positive, minus get positive 0.3. So actually this equation is minus x minus 2, right? And this is modulus x minus 2. I'm saying in this range, this thing is equals to this thing, only in this range, right? Because we know that the inside the value will be negative. So now we come to here, then you can always repeat my video again and again until you get it. So now the third part, okay, now my number is still smaller than 3 and inside is a negative number, so I need to put a minus sign inside, because it will be reflected. Okay, the negative number will be under the modulus will become a positive number. By adding a minus, this number negative would also become a positive number. So within this range, this is equals to this, right? So then the next thing is I'm trying to smaller than 10, so I want to find the range of x values that satisfy both of these inequality at the same time. So x plus 1, x minus x is 0, minus 2x. So I have a minus 2x. Then I add the constant up. 1 plus 2 is 3. 3 plus 6 is 9. Correct? So smaller than. So x smaller than. This one is 10 minus 9 is 1. 1 over. So 1 over 1. So okay. So now I just leave it like this first. So minus 2x that this bring over is 1. So when I divide by minus 2, x must change the sign to minus half. Notice I have switched from this to this because I'm dividing by a negative number. When divide by a positive number, you don't have to change this. Or when divide by a negative number, you definitely has to change the inequality sign. This is simple to understand if you take this as the example. Minus half is smaller than 1, but if I multiply a negative 2 on both sides, this becomes 1 and this becomes minus 2. 1 is greater than minus 2. If I don't change this sign, then it doesn't make sense because they will be minus 2 greater than 1, which is wrong. Therefore, I have to change the sign when I multiply a negative number on both sides. So this is x greater than minus half. Let's see, x greater than minus half, does it overlap with this part? Right, so we'll see that, let's say if, where is minus 1? Minus 1 is here, minus half is here. Now common mistake is to think that minus half is here, which is wrong. So minus half is greater than minus 1. Right, so this region is minus 1 to half, but we say that x greater than minus half. X greater than minus half means that it has to go here. So only in this region does this equality hold, and this inequality yield this inequality. So we must this bond out of this. So they are actually, we have to take the intersection, not the union of this part. Right, so that's it. X greater than minus half, right? If I substitute, I believe I will get something close to 10 if I substitute. So that means x, from here we get the inequality x greater than minus half and smaller than 2. Okay, so this we gotten. So we have checked for x between. Do I need to check for x equals to minus 1? So I remove this for a moment because I need more space. So if I check, my intuition is that, okay, the values actually is all the way from 4 1/4 down until it hits x greater than minus half. Any value lower actually will be greater than 10. So if I not believe it, so I will just try x equals to minus 1. I will try this. So when x equals to minus 1, what happens? When x equals to minus 1, I just substitute, because it's a single value, I just substitute inside. So minus 1 plus 1 is 0. Okay, plus minus 1 minus 2 is minus 3. Minus 3 modulus, so plus 2 times modulus of minus 1 minus 3 is minus 4. So equals to, so this modulus minus 3, you get 3 plus 2 times 4 is 8. So 8 plus 3 is 11. 11 is greater than 10, which is not what we want, because we want something that's smaller than 10. Therefore, this part is no. We don't want to include these values under the range of x. Right, and the next thing is what if x is smaller than minus 1? So when x is smaller than minus 1, then this would be a negative number. Then in order to be the same as the modulus, I will need to add a negative sign in front. I'll need a negative sign in front, and I'll need a negative sign in front for the same reason as well, and the negative sign in front of this, because when x is smaller than minus 1, I substitute this into this into this, all of them will give me negative number within, but modulus means I need to reflect them with the negative sign so that they become positive numbers. So let's check if these values hold. So minus x can minus 2x, minus 2x minus 2x will give me minus 4x. So minus 1 plus 2 will give me 1 plus 6 will give me 7. 7 is smaller than 10. So this one will give me smaller than 3. So minus 4x smaller than 3. And let's say this implies that x is greater than negative 3/4. And get x greater than negative 3/4. If I do this, this is negative. Okay. So here on the number line, x smaller than minus 1 is here. Right, this is minus 1. negative 3/4 is negative 3/4 is here. So x greater than negative 3/4, and here it does not overlap. So when there's no overlapping, we reject the both answers. Okay, so let's just do a quick check. There's no error here because the number seems rather strange. Minus 2x minus 3 smaller than 10. So minus x minus x minus 2x minus 2x minus 2x minus 4x minus 1 plus 2 is 1. 1 plus 6 is 7. So 10, 7, 3, 3 minus 3/4. Yes, indeed, right? There's no overlapping part, so we have to reject this answer. Okay, so when we reject this answer, that means now what are the, finally when we conclude, what is the numbers, what is the range that we want? We want everything from, so I erase this to give me more space, not that these workings are no good. So that means what, from 2, just now from we accepted 2, then proceed downwards, we accept up to minus half. So the number line here, minus half, I do not include, so it's a white dot, right? I don't have a underline there. So from 2 to minus half, I would accept. Therefore, the range, the solution for this equation is just x greater than minus half and smaller than 4 and 1/4, which is 17/4. Or I can write is this way, it's the same. So that is the solution for this question. Thank you. No, so thank you.